Hi, my name is Stefano Renzetti, and I work at Wageningen Food and Biobased Research as the expertise leader and senior scientist in the area of food formulation, which focuses on linking ingredient functionality to food structure and texture and also to sensory perception. In this short video, together with my colleagues, I would like to provide you some information on a new research initiative called Smartgrains, which is focusing on functionality-driven fermentation to valorize whole grains from cereals and legumes and also their byproducts. The project involves a multidisciplinary team with experts that are covering aspects related to fermentation, physical chemical properties of ingredients, flavor science, spectroscopy and chemometrics, and also data science. So the background for smart grains is that, whole grain cereals and legumes are actually recognized as an essential element in a planetary healthy diet. So if we look at recent research, we see that, for instance, a diet that is low in whole grains consumption, it's actually related to higher chance of mortality, so higher mortality rates, more than actually a diet low in fibers. And that is because, let's say whole grains are not only rich in fibers, but there are several important co-passengers such as phytosterols, polyphenols, vitamins, and minerals that are very important, let's say, in the diet and hence for our health. At the same time, uh, byproducts from grains, like for instance cereal brands, they are currently largely used for feed instead of human consumption, but they could be, for instance, functionalized and added back to the refined ingredients from the grains to provide both nutritional benefits but also technological ones. However, there are still major challenges in the more widespread use of, let's say, whole grain ingredients, which are mainly related to technological and sensorial aspects, which are still, let's say, limitations with regards to food applications. And also, it is important with looking at consumer trends to use, for instance, clean label solutions to functionalize these ingredients. And fermentation, it's a traditional process that actually offers opportunities to modulate both flavor and functionality. But the challenge is that, identifying optimal fermentation condition is still difficult. So there are a lot of, let's say, research done on fermentation, but these, let's say, provide only limited information actually on how to optimize. In order to address these challenges, um, Smartgrain will be working on using high throughput screening technologies to monitor fermentations and fermentation, including both microbial fermentation but also enzymes and combinations thereof, applied to whole grain, for instance, flours, their byproducts, to basically find more efficiently conditions for improved techno-functionality and condition for improved sensory properties. And these, let's say, large data sets of these two aspects that will be collected with these high throughput screening technologies will be further analyzed using data science tools, so artificial intelligence tools, which combined with, for instance, advanced spectroscopy like sensor and rheological techniques and so on, will actually aim to find the right fermentations condition to combine both functionality and flavor profiles, especially looking at volatiles of interest, depending on the specific application. In order to achieve these aims, Smartgrains is currently arranged into 4 main research work packages. The first one focusing on screening of flavor volatiles using combinatorial fermentations and monitoring both growth and volatile generation. Work package 2 is focused on performing combinatorial fermentation and actually screening for technofunctional properties that will be defined depending on the applications of interest. Work package 3 is focusing actually on data modeling, so using the AI tools on the large data set obtained for work package 1 and work package 2 to identify, let's say, conditions which are matching desired targets that can be, for instance, related to benchmarks that are defined within the project, and also predict, for instance, promising fermentation conditions that go into the desired direction in terms of optimizing flavor and techno functionality. And then work package 4, which is related to the, in fact, the product application, where we will perform techno-economical analysis of the fermentation condition to create, in fact, a commercially useful ingredient, and let's say validation of the functionality of the ingredients in food applications that are of industrial relevance. So in essence, Smartgrains will combine expert knowledge and advanced tools for exploiting the power of fermentation to then functionalize whole grain ingredients and byproducts. That means that the project will focus on using a large collection of cultures as well as enzymes for these purposes, set up and use high throughput screening technologies to monitor fermentation, to monitor, let's say, flavor volatile production, and also to monitor, let's say, functionalities of the fermented substrates. For instance, looking at gelling, water binding, viscosity, depending on, let's say, the specific application of interest, by combining rheological techniques with spectroscopy. And finally, to analyze these large data sets with AI tools and make predictions of the fermentations conditions that best match the desired profile in terms of flavor volatiles and functionality. And last but not least, validating these solutions in food applications of commercial interest.
Hello, I am Martijn Becker, the expertise leader of the Microbial Cell Factory team. In this project, I will support my colleague Stefano with the fermentation activities. In work package 1, we will focus on 2 main activities. Firstly, we will set up a high throughput screening approach to determine a volatile formation during the fermentation of the intended substrates. Secondly, we will explore alternative screening technologies using cell-based assays for non-volatile flavors that may be relevant to our partners. All data will be collected in a centralized database, enabling comprehensive analysis using various statistical tools and machine learning algorithms. For the mentioned data generation, we will use our tested screening platform, which allows us to perform over 500 fermentations per month. This platform tracks fermentations using both near-infrared reflectance and high-throughput flavor volatile analysis via a direct injection Orbitrap mass spectrometry systems. All data are normalized into concentrations of selected key food odorants and adjusted for their odor activity value.
Work package 2, related to functionality screening, will mainly work along these lines. First of all, based on the application of interest, we will identify what are the most relevant physical-chemical properties, as mentioned, for instance, gelling, water binding, and so on, to be tailored. Next, well, setting up methodologies to monitor the functionality of the fermented substrates, and for this, the intention is to use small-scale physical measurement, for example, rheology in microtiter plates, viscosity measurements, for instance, using pipetting robots, and combine these with advanced spectroscopy to make a link between the physical measurements and the spectroscopy data, so that later on, for instance, it is possible to either rely on spectroscopic analysis as basically sensors to monitor the effect of fermentation on functionality, or to provide also complementary information about the changes occurred in the fermented substrate, which link to changes in functionality. And well, based on this setup, then in this work package also, let's say, the fermentations will be performed by combining different substrates and microbes and varying fermentation conditions, which basically, well, it's done in fact in combination with the fermentation related to flavor screening. And this large data set then will be basically provided to work package 3 for data analysis. And these slides, for instance, provide an example of how this would be applied in practice, where in fact we have a screening model based on microtiter plates, combining, let's say, the substrates can be, let's say, from cereals, legumes, or their byproducts, and then in combination with microorganisms, as well as with the use of enzymes. And in this case, the use of enzymes, it's also to prove hypothesis, since with the enzymes, specific changes in the substrates can be made, and in such way prove, for instance, specific hypothesis on how changes in the molecular structure of the fermented substrate relate to specific functionalities. And then the fermented material can be analyzed, as mentioned, with a combination of physical measurement using rheological techniques applied to this small scale, combined also coupled with the spectroscopy measurement of the same material. And this is something that, for instance, we have already built in other projects, where we couple, for instance, measurement of viscosity with automated robots, and we couple the changes of viscosity with changes in the molecular composition, and we can predict the viscosity also from spectroscopy measurements.
All collected data will be analyzed using machine learning algorithms to determine the optimal conditions for achieving the desired flavor profile and texture. We have previously developed tools to efficiently compare various conditions and select the most optimal combination of strain, substrate, and growth condition to ensure the functionality you may be interested in.
Well, and with regards to work package 4 on food applications, what we foresee for this work package is that at the start of the project, we will define the food applications of interest. We will also define what are, let's say, the flavor volatiles and the functionality related to texture or texturizing function that are of interest based on the applications. We will also then collect, for instance, benchmarks related to flavor profile and functionality that can be characterized as targets. And well, based on that, we will actually also elaborate hypotheses on, let's say, how the substrate should be modified in relation to texturizing properties related to the specific food applications. And during the project, well, as mentioned, we will conduct the fermentations and perform the screening so that we can test the hypothesis related on functionalization with, as mentioned, let's say, microbes, enzymes, and combinations thereof. What we will also do is to perform on promising condition techno-economical analysis of the whole production process to make sure that, well, what design makes sense also in terms of commercial viability. And condition of interest will be, let's say, upscaled from the microtiter plates to, let's say, half a kilo of ingredient, so that can be tested in food applications and hence validate, let's say, the functionality in terms of both flavor as well as texture or texturizing function of the ingredient. In terms of deliverable, overall, Smartgrains aims to basically provide whole grain cereals and or legume-based ingredients or based on byproducts which are valorized for tailored food application. Well, the use of, in fact, food fermentation as a traditional processing strategy, but advanced by means of integrated high throughput screening and data science to find optimal solutions with regards to ingredient functionalization. The project will also provide, let's say, screening tools and predictive models to functionalize these substrates, focusing on, let's say, texture, functionality, and aroma profile. And finally, having the validation of the functionality of these ingredients in industry level relevant food application, and also validated in terms of the technology, the economical feasibilities of these developments.